ascent formula, means the height in terms of radius of tube. Here R was the radius of meniscus. If we wish to calculate in terms of radius of tube, then see what will happen. If this is your tube, and this is your meniscus, so its radius would be this. The whole circle of the meniscus would be like this red circle, yes or no?
Yes, ma'am.
So if I say capital R is the radius of the meniscus. Now see, this tube will also be having its own circle. This tube will also be having its circle. Let's say small r is the radius of tube. Now see, it will form a right angle triangle. If we put this center of O1 is the center of the tube and O is the center of the meniscus. Now see, if we take this track in triangle, and let's say this point is M, O1, OM, in this triangle, if we see cos theta is base divided by hypotenuse. What is the base from this triangle? See, this is theta. The opposite side to the angle is known as the perpendicular. The adjacent side to the angle is known as the base. And the third side is known as the hypotenuse. So since base is this line, this is small r. Understood? This. So your
Yes, ma'am.
cos theta would be small r divided by hypotenuse of this triangle is capital R. Now see, you have a relation between capital R, small r and cos theta now. See, so capital R would be small r divided by cos theta. Now, what was the formula for height? Height's formula was 2s capital R rho g, where capital R was the radius of the meniscus. Now we wish to calculate it in terms of radius of tube. So let us substitute the value of radius of meniscus from here. So h would be 2s divided by this whole term, means r, cos theta will go up, divided by rho g. So this is your final formula, where theta, this is your ascent formula. And now the r, this r is now the radius of t. So if you have the data for radius of meniscus, use this. If you have the data for radius of tube, use this. Just note this down.
Done, ma'am.
Okay. Now see, how will we realize whether the liquid will rise or fall? So for that we have the formula H is equal to 2s cos theta by ROG that we have seen. If your theta is less than 90 degrees, then your angle is acute. Definitely, if your angle is acute, then you will get this in positive because this cos theta is acute, cos theta is less than 90 degrees, and you get the values in positive. So if your height is positive, then it means it will rise. Means the liquid will rise. And if your theta is negative, like if your theta is coming off use, so theta is more than 90 degrees, height will from this formula, it will be negative. It means the liquid will fall. So for example, for acute is water. Water makes an angle of less than 90 degrees with the liquid surface and the solid container. Similarly, mercury, the opposite happens with mercury. If you take a vessel, you put water in it, and you take a narrow capillary tube, then water level will be more in this. Similarly, if you take this vessel and you put in mercury over here, so had the level been here, now the level of mercury would be here. It will fall down. Clear?
Yes, ma'am.
So note these points. I've written it also. And
Done, ma'am.
okay, just try a numerical based on this formula only, just ascent of sap. I'll draw the figure. Just note this down and try to find out the difference in level of water. I'll draw it. So see, diameter is 3 millimeter. This is for the narrow tube, and 6 millimeter is for the thicker one. If this is the height of the narrower tubes, columns, water. If the water's level is still here, this is the height of it. And since this is thicker, the water won't rise that much as compared to this. So this will also have its height. Let's say if this height is h1, this height is h2, then you have to find out this difference coming out in height. This difference. Just try at least once, and I'll help you.
Okay. Ma'am, can you explain it?
see, if you have to find out the difference between the height. So height, the difference would be if you subtract h2 from this h1, will we be left with small h only? See, if you subtract h2 from this longer h1, will we get the difference h?
Yes, ma'am.
Yes. So h will be equal to h1 minus h2. So see, the formula for h that we have is 2s cos theta divided by rho g, r rho g. Now see, rest all the things are same. 2 is constant, surface tension is same, cos theta, theta is already given to us 0. Density, the liquid is same, water is there. Acceleration due to gravity is same. Just the difference comes in the radius. So see, if you take all these terms common from here, 2s cos theta divided by rho g, you will be left with 1 by r1 means the radius of this tube minus 1 by r2, the radius of this tube. Now see, r1 would be r, if d1 is 3 millimeter, then r1 should be 3 millimeter divided by 2. That is 1.5 millimeters. So let's convert millimeters as well. 10 to the power minus 3 meters. Then r2. R2 is 6 millimeters divided by 2. So this would be 3 millimeters. So instead of milli, you can write 10 to the power minus 3 meters. So radii we have got. Cos theta is 0. Surface tension is there. Density of water is 1000 kg per meter cube. You have to remember this value as well. So are we sufficient with all the data now?
Yes, ma'am.
Yes. So let us just put in the values. So the difference in height would be 2, surface tension is 0.07, cos 0 is 1 divided by rho. Rho is 10 to the power 3. Acceleration due to gravity, let's take it as 10. Then 1 by r1 means 1.5 into 10 to the power minus 3 minus 1 by r2, 3 into 10 to the power minus 3. So on solving this, you will get the answer approximately around 0.4.7 into 10 to the power minus 3 meters. So just note this down and see whether you're getting this or not. Is this question clear to you? Have you understood the solution?
Yes, ma'am.
Okay, so just note this down. Wherever you get stuck, you can ask me. Written?
1 second, ma'am.
Okay.
Done, ma'am.
See, just note down few points for the understanding of the next question. H is equal to 2s cos theta divided by r rho, see, not capital R, small r. R rho g. Now see, 2 is a constant number. Surface tension remains same. Theta is a constant value. Acceleration due to gravity, that's a constant. Density of the liquid will also remain same. But the radius and height differs, that we have seen in the previous question as well. So if rest of the terms are constant, then h multiplied by r gives whole constant term. H product of h into r is constant for a given liquid. And one more thing, if I take a vessel, I have put in the liquid over here, and this is the tube that I have taken. The liquid has been filled till here. Let's say it has been filled over till here. So height h is the height above the liquid surface, the water surface, that is h. Now, even if I tilt it, if I have tilted it, this is my liquid now. See, now for calculation of height, this height that was initially taken before tilting will be considered now also. You won't be taking this length. All right, so you have to take the perpendicular length only from the surface of water. So even if you tilt it by some angle, let's say theta, then also the height that you will be considering in this formula, that would be this vertical perpendicular height only. Clear?
Yes, ma'am.
Okay, so just note these 2 points as well and note the question. First, note these points. Just draw these two.
Done, ma'am.
Okay, Aisha. See, this is the question which these 2 points will help you in solving the next question. So note down the question and then try it yourself. Then I'll help you.
Ma'am, how will we find the radius?
See, for the first part, water rises in a capillary tube to height 2 centimeters. In another capillary tube, whose radius is 1/3 of it, how much water will rise? We have just told you relation. H multiplied by R is a constant. This means H1 R1 is equal to H2 R2. Now see, what is height 1? H1 is, what is height 1? Tell me.
2 centimeter.
Yes, 2 centimeters. See, if I say R1 is R, H2 is unknown to us. We have to calculate. R2 is 1/3 of the first one, means R divided by 3. So from here, we'll be able to calculate H2. See, 2 into R1 is R equals to H2. R2 is R divided by 3. So R would get cancelled. And from here, we can see H2 is equal to 6 centimeters. Clear? How have we got the second height?
Yes, ma'am.
See, for the second part, it is saying if the first capillary tube is inclined at an angle of 60 degree with the vertical. Means if this was the vessel, this was the liquid filled, this is the tube. Tube is making an angle of 60 degree with the vertical. So how much will this angle be? If this is 60, this will be, if one is 60, the other complementary would be 30 degree. Yes, because this is 90 degree.
Yes, ma'am.
This hole is 90 degree. So this is 60, this is 30. This is 30 degree. Now see, if you take sine theta, means if you take sine 30 degree, sine theta is perpendicular upon hypotenuse. So perpendicular is this, and this is our height h by hypotenuse. Hypotenuse is the length, this length. This is the length only. So this is L. Now see, we have to find the length L. What will be the position of water in tube? So let's find the length. So sine 30 degree would be equal to h. H was 2 centimeter. Yes, 2 centimeters was this height. 2 divided by L. So see, sine 30 degrees half. So we'll getting L is equal to 4 centimeters. Understood?
Yes, ma'am.
Okay, just note this.
Done, ma'am.
Now see, one topic that we have is rise of a liquid in a tube of insufficient length. Means now we were taking the length of capillary tube which was sufficient in its height so that the water level or the liquid level which used to rise in here, it was sufficient for the tube. Now see, what will happen if the tube had to rise more, but the length of the capillary tube or the height of the capillary tube is not much. See, if this is our container, this is the liquid, and I have taken a capillary tube, and let's say the height of this tube above the surface of water is 3 centimeters. But the height of the ascent, that the rise of the water that has to occur, is based on this formula 2h divided by r rho g. This is, let's say, 3.1 centimeters. So is 3 centimeters sufficient for 3.1 centimeter, or is it less?
Yes, ma'am.
If the height of the tube is 3 centimeters and the height to which the liquid has to rise is 3.1 centimeters. So is 3 centimeters sufficient for 3.1 or this is less?
It's sufficient.
It's not sufficient. 3.1 centimeter and 3 centimeters are not equal. Yes or no? We
Yes,
need
ma'am.
more height. So what is expected from it? It is expected that the liquid will emerge like a fountain. Yes or no? It seems like
Yes,
this if
ma'am.
the tube is not, but actually this does not happen. What happens is that if this is the fluid, if this is our liquid, then see the water or the liquid will come to the surface and it will expand its radius. See, why will it expand its radius? We have seen this now, h into r was constant. So it means h is inversely proportional to r. So if height is less, so radius should be more. If height is less of the capillary tube, then it will expand its radius like this. All right, so it won't emerge like the form of fountain from the upper end because it will violate the law of conservation of energy. So radius of meniscus increases so that the liquid does not spill. Radius of the meniscus increases so that liquid does not spill. Okay, and these are the applications of capillarity. So note this page as well.
Okay, ma'am. Done, ma'am.
Okay, see, so these topics considered when the fluid was at rest. We didn't consider any term like acceleration or velocity. So that was about hydrostatics. Now we'll be beginning with hydrodynamics, means study of properties of fluids when they are in motion. Branch of physics which deals with the study of properties of fluids in motion is known as hydrodynamics. Before till before discussing this, it was hydrostatics, the portion that we were discussing. Now we are dealing with the fluid will also be in motion. Okay, now see, we have seen that when a solid surface moves over another solid surface, their relative motion is opposed by a force. What is that force? When two solid objects move over the surface of one another, there is an opposing force.
Yes, ma'am.
Which force is that? Remember it from your laws of motion.
It's
If see
a
this
frictional force.
exactly, if this is moving there, a frictional force acts in the backward direction. That is the frictional force. So frictional, it is opposed by this movement is opposed by friction between the surface. That is solid friction. See, a fluid also moves in the form of layers like this. A fluid moves in the form of layers. So when a layer of fluid moves over another layer, their relative motion is opposed by internal friction of the fluid. This was the frictional force between the solid object. Here, the opposing force between the layers is the internal friction force. So this property, this fluid friction, that is called as viscosity. So the property of a moving fluid to oppose the relative motion between its layer is called as viscosity of the fluid. Like if these layers are moving forward, then a backward viscous force will be acting. The way we have frictional force, which opposes the motion and is acted backwards, acted along the side opposite to the motion. Similarly, we have viscous force, which acts along the opposite side of the motion. So viscosity is the property of fluid due to which an internal frictional force acts between when a liquid is in motion. Is this clear what is meant by viscosity? Property of moving fluid to oppose the relative motion between its layers, that is known as the viscosity. So this viscosity is that property of fluid which indicates its internal friction. So the greater the viscosity of the fluid, the greater is the force required to cause one layer of the fluid to slide fast than another layer. Like you can say viscosity of honey is more than viscosity of water. You can compare it using your touch only by touching it, honey and water. Now see this force that we get, this backward force that is developed due to viscosity of the fluid. This force is known as viscous drag, or you can say viscous force. So viscous drag is backward dragging force, backward side dragging force, which is developed, which opposes the motion of the liquid layers and it acts tangentially on the layers. So when a liquid or a fluid flows, a backward dragging force or viscous drag is developed between its layers that retards the motion of the liquid, means it opposes the motion. The viscous drag acts tangentially on the layers of liquid. So is viscosity clear to you?
Yes, ma'am.
The cause of viscosity is basically the internal friction of fluid, which opposes the motion of one layer of fluid past the another. All right, so just note this also.
Done, ma'am.
See, if we enlarge those two layers, I've just taken upper two, first two layers, let's say. This is one layer of the liquid and this is another layer of the liquid, just to enlarge it for better understanding. If I say A is the area of this layer, A is the area of the layers which are overlapping. There is some separation between these layers, that very small separation. Let's say that is dx. So when the layers move, they move with a certain velocity. So let's say v is the velocity by which it is moving. And since it is relative velocity will also be there. So dv will be adding it. Now see if the two layers are moving in the right hand side direction. Can you tell me what is the direction of viscous force developed? Yes,
It will be in the opposite direction.
opposite direction. So if it is moving in the right hand side, viscous force will occur in the backward direction. That is this viscous force. Now see dv over dx is the velocity gradient. If you divide any quantity by time, that we call it as rate. Like you take acceleration as dv by dt. So this is rate of change of velocity. When you take velocity as dx over dt, you take it as rate of change of displacement. But when any quantity is divided by distance, then we call it as gradient. So if velocity is divided by dx, we call it as velocity gradient. Now see if these are the some parameters that I've taken, then we are calculating viscous force. So the viscous force depends on the area that we have seen, area of the layer. Viscous force also depends directly on this velocity gradient, dv over t. If I combine these terms, it would be F is directly proportional to A dv over dx. Now see, how can we remove the sign of proportionality? Yes, how do we remove sign of proportionality? Whenever in mathematics you have to remove the sign of proportionality and make it into a form of equation, we put an equal to sign along with a constant. And the constant used over here is represented by this symbol eta, A dv over dx. So this is your formula for viscous force developed. This is the formula for viscous force developed. So eta over here is the coefficient of viscosity. Eta here developed is the coefficient of viscosity, the constant that we are using. F is equal to eta A area dv divided by d. Now see this coefficient of viscosity depends on two factors. One is the temperature. The other one is the nature of material. So coefficient of viscosity depends on the temperature and the nature of the material. And what is the direction of viscous force? So the direction of viscous force is opposite to motion, the way we have it for friction. Opposite to motion. Clear this formula?
Yes, ma'am.
All right, so note it from here as well.
Ma'am, can you scroll down? Done, ma'am.
Okay. See, just do a very small, easy numerical based on this only. The same formula will be used. These are the two layers. This is the area of the layer. This one is moving with 10 meter per second. This is at rest, the second layer. And the distance between them is 5 millimeters. So coefficient of viscosity is 10 decapoise. Decapoise is already in SI unit. This is the SI unit, so don't convert it. Now using the above formula that I've told you, calculate the viscous force. Just try this. This is an easy one. Just put the data in the formula.
Ma'am, we need to convert 5 mm into meters, right?
Yes, yes. You have to take everything in SI unit, meters.
Ma'am, what will A be?
See, area of the layers is given as 2 meters square. This is the A. Alright, area A is given as 2 meters. Fine.
Yes, ma'am. Ma'am, is it 40,000?
How much is your coming?
40,000.
Yes, 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 absolutely. 40,000. Because decapoise is already in its SI unit. So you just have to convert 5 millimeter in the SI unit. Yes or no? So you
Yes,
just
ma'am.
put in the values. Fine. Just now see the definition of coefficient of viscosity that we have. Means if F is equal to eta A dV over dx. So from here, if we want to calculate eta, means the symbol we call it as eta. So it would be F dx divided by A dV. So once you put in all the values, you will be getting, this is Newton, it's meter, area is also meter square, and velocity is meter per second. So meter will cancel this meter, and we'll be left with Newton meter inverse square seconds. So the SI unit for the coefficient of viscosity is Newton per meter per second. Now see, Newton seconds per meter, this is also called as decapoise. And if you wish to take the CGS unit, then this would be dyne second per centimeter. And the CGS unit is poise. So 1 decapoise is equal to 10 poise. So if you want to convert SI into CGS, this is how the conversion will work. All right.
Yes, ma'am.
Now see, coefficient of viscosity of ideal liquid is inversely proportional to its temperature. So effect of temperature, this point represents the effect of viscosity Effect of temperature. Effect of temperature on viscosity. How viscosity is affected by temperature. So effect of temperature on viscosity. So viscosity on increasing temperature, viscosity of liquid decreases, which is inversely proportional. But in case of gases, it is directly proportional. And how it is directly proportional, that we'll discuss in kinetic theory of forces later on in thermal unit. So is this clear?
Yes, ma'am.
So note this also.